is Algebra Lesson 8-2, Scientific Notation. Hopefully you've done scientific notation in some of your science classes, so this should not be new to you. It should be something you've seen before, and hopefully it will just be a good refresher. Scientific notation is a number expressed as the product of a power of 10 and a numeral greater than or equal to 1 but less than 10. In other words, what that means is you have to have a number that has only one digit in front of the decimal place, like 3.7. And then you have to have it multiplied by a power of 10, and it can be by 10 to the first, 10 to the second, 10 to the negative 7th, whatever. So it's a number expressed as the product of a power of 10 and a number greater than or equal to 1 but less than 10. So it has to have only one digit in front of the decimal point. Standard notation is the normal way of seeing a number, like 372. That would be standard notation because we normally see numbers like that written quite frequently. The purpose for scientific notation is to write numbers that are really, really, really large or really, 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 really small in an easier fashion that can be read and manipulated much better. One of the things that you need to be able to do is recognize if numbers are in scientific notation. So let's take a look at some things. We're going to determine whether each number is in scientific notation, and if it is in scientific notation, explain why it is, and if it is not, explain why it is not. So we have the number 3.42 times 10 to the negative 7. This number is written in scientific notation. So yes, it's in scientific notation, okay, because it's your number is greater than or equal to 1 but less than 10. Okay, 3.42 is greater than or equal to 1 but less than 10. And we have a power of 10. So that one's written in scientific notation. If we look at number 2, we have a power of 10, so it checks off that box. But if you look at 0.04, 0.04 is not greater than or equal to 1. Okay? So this is not in scientific notation because 0.04 is less than, or it's definitely less than, not even less than or equal to, it's just less than 1. So it doesn't work. It has to be greater than or equal to 1. Okay? Let's look at the next one, 54 times 10 to the 4th. Again, I have a power of 10, but if I look at this, 54 is greater than 10, so this is not in scientific notation either, because 54 is greater than 10. So being able to determine if something is in scientific notation is really quite important. The next thing we're going to do is to write numbers in scientific notation. In scientific notation, you use positive exponents to write a number that is greater than 1, and negative exponents to write a number that's between 0 and 1. Okay, so if we have the following number, which I'm sure most people can't even read. Okay, this is 234 billions. Okay, so if we need to write this in scientific notation, when a number does not have a decimal point expressed, it's always at the end of the number. So my decimal point would be back here. I need to move it all the way to here because you can only have one digit in front of the decimal place. So I need to change 234 billions to 2.34. And it's going to be a power of 10. And this is a big number. So if it's a big number, my power of 10 should be positive. How many places did I move my decimal point? I moved it 3, 6, 9, 10, 11 spaces. So my power of 10 is to the 11th power. So I have 2.34 times 10 to the 11th power. The next number we have, tens, hundreds, thousands, 10,000, 100,000, millions, 10 millions, 63 millions, 10 millions, excuse me. Okay. So I have to change this to a number that is greater than or equal to 1. So I need to change my decimal point from here all the way to here. So it's going to be 6.3 times the power of 10. Now this is a really small number. Since it's a small number, it is less than 1, my exponent has got to be negative, okay? Because this number is actually, it's between 0 and 1. Okay, so if my number is between 0 and 1, I have to have a negative exponent. This tells me I need a negative exponent here. So I just need to count the number of spaces I moved my decimal point. And that would be 1, 2, 3, 4, 5, 6. So this would be to the negative 6th power. Because it's a small number, it has a negative exponent. When it is a big number, it has a positive exponent. So 0.2362. I need to move my decimal point one place to the right, so I get 2.362 times 10 to the one right, which means we made a smaller number bigger, so we have to have a negative exponent. 0.00325. My decimal point goes between my 3 and my 2, so it's 3.25 times 10. I moved that decimal point 3 places, but I made a smaller number bigger, so it's a negative 3 exponent. Right? Because my number was less than 1, and I made it bigger than 1, my exponent goes to a negative number. Let's look at number 5 here. 139,500. My decimal point has to go between the 1 and the 3, so 1.395 times 10. My decimal point would have been here. It moved to here. That is 5 places. It's a positive power of 10 because 139,500 is larger than 1. So I have a positive power of 10 here. Okay, the next number, 46,205,000. My decimal point has to go between the 4 and the 6, and I have to list all the digits until I get to a bunch of zeros in a row. Okay, so I have to list 4.6205. I can't stop at the 4.62 just because there's a 0 here. Does not mean I can stop. I have to list all the digits till the only thing left are zeros. And this is going to be a power of 10. This was a number larger than 1, so it's going to be a positive power of 10. I moved that decimal point from here all the way to there, which is 3, 6, 7 places, so it's power of 10 to the 7th. And the last number. It's a smaller number. I'm going to make it bigger by moving that decimal point between the 1 and the 3, so I have 1.35. I can leave the 0 off. I can put it on, but I can leave it off so it doesn't change the answer. Times a power of 10. This is going to be a negative power of 10 because this number is less than 1, and this number is greater than 1. I moved that decimal point 4 places, so it's going to be a negative 4 for an exponent. So writing numbers in scientific notation is not difficult. The next thing you need to be able to do is take a number from scientific notation and write it into standard form. And if I need to write something in standard form, simply remember this. If you have a positive exponent, a positive power of 10, move the decimal point to the right. If you have a negative power of 10, move the decimal point to the left. Okay? So positive exponent goes right. Negative exponent goes left. So here I have 3.2 times 10 to the 5th. So normally my number would look like this. I have 10 to the 5th, so I need to move my decimal point 5 places to the right. 1, 2, 3, 4, 5. All over the dips, you can add zeros. And I can rewrite my number so it's nice and tidy. So it's 320,000. Another way of looking at it is to get to the end of the 2, I have to move it 1 place. I have to move it a total of 5, so I need 4 zeros after that. 1.25 times 10 to the 3rd means I need to move my decimal point 3 places to the right. In doing that, 2 places would get to the end of the 5. That 3rd place would get me to the 0, so it's 1,250. 4.8 times 10 to the negative 3rd. So here I have 4.8. Negative 3rd means I'm going to go left. I'm moving my decimal point to the left because it's a negative exponent. So 1, 2, 3, put the decimal point there, put zeros in front of it. So it becomes 0.0048. 48 ten thousandths. 5.698 times 10 to the negative 9th means I need to move my decimal point 9 places to the left. 1 place to the left will get me in front of the 5, so I need 8 more places. So I'm going to need 8 zeros in front of my 5. 1, 2, 3, 4, 5, 6, 7, 8. 5, 6, 9, 8. A very difficult number to read outside of scientific notation. It's much easier to read that as 5.698 times 10 to the negative 9. Okay? Rather than trying to read that as 5,698 billions. Now, scientific notation can also be very useful when comparing and ordering numbers. You simply need to convert all the numbers to scientific notation, compare the powers of tens and the decimals, and then order it from least to greatest, or greatest to least, whichever one they're asking for. Here, I'm going to ask you to order it from least to greatest. Some of these numbers are in scientific notation, Some of these numbers are in partial scientific notation. It looks like they're in scientific notation, but they really aren't. And some of these numbers are just in standard form. So it's just best to convert them all to scientific notation before you compare things. So I'm going to take all these numbers and put them into scientific notation. This one, 1, 2, 3, I need to put the decimal point between the 6 and the 3. Now it was 10 to the 5th. It's a smaller number, so it would have a negative exponent. So I have a negative exponent for this part and a positive exponent for this part. Okay, so I had if I would have just been writing this, this would have been times 10 to the negative third power. So I have a negative 3 and a positive 5, which makes this times 10 to the negative second power. An interesting little trick. Okay. The next number, 6.03 times 10 to the 4th, is in scientific notation. So I can leave it as 6.03 times 10 to the 4th, so I'm going to. 6,103 would change to 6.103 times 10 to the 1/3 place. And the last one, this one right here, and I'll just put it over here, I need to move the decimal point one place to the left. So it becomes 6.31, but instead of 10 to the 3rd, this is now 10 to the 4th. Oops, the first one should be 10 to the positive second, not negative second. Negative 3 plus 5 is 2, not negative 2. There we go. So I have 6.3 times 10 to the 2nd. Then I have 6.03 times 10 to the 4th, 6.103 times 10 to the 3rd, and 6.31 times 10 to the 4th. So the smallest number is obviously the number that's the smallest power of 10, which would be this one right here. Then I look to see if I have any powers of 10 that are in the 3rd power. That would be this one right here. So this is the 2nd power. Then we have two numbers that both have the same power of 10. Okay, this number here has a 10 to the 4th. This number here is 10 to the 4th. So now we have to look at the decimal parts of the number. If I look at this is 6.03 or $6.03. This is 6.31 or $6.31, meaning that this 6.03 times 10 to the 4th is slightly smaller. So this is the 3rd number, and this is the 4th number. Remember, when you put things in order from least to greatest, you have to put them back in their original form. So to list these numbers in least to greatest, I have to put them back in their original form, which would be listed as 0.0063 times 10 to the 5th. That's my smallest number. Followed by 6,103, because that was its original form. Followed by 6.03 times 10 to the 4th. And last but not least, 63.1 times 10 to the 3rd. Whenever you order things from least to greatest, you have to put them back in their original form. As annoying as that is, this has to be written in this form. Very annoying, but works. Last thing we're going to do is simplify things and use scientific notation. This is just like using the distributive property, except for most people will think, oh, I need to distribute here and I need to distribute here. That is wrong. You do not do that. Because literally, 8 times 10 to the negative 4th is one number. It's not two numbers, it is one number. So you only distribute the 6 to the 8. Okay, so the easiest way to do this is just think, I've got to multiply this by this. 6 times 8 is 48 times 10 to the negative 4. Now I need to put that in scientific notation, because it's not in scientific notation. To put it in standard form, okay, if I wanted to write this in standard form, I need to move the decimal 4 places to the left, so this would be 0.0048. Now to write that back in scientific notation, it would be 4.8 times 10 to the negative 3rd. Or you can look at it up here and say, I need to move the decimal from here to here. It went 1 to the left, so I took a bigger number and made it smaller, so I need to add to my power of 10, so it goes from a negative 4 to a negative 3. Some people can't do that transition, so they write it in standard form, then go from the standard form to the scientific notation. I have no preference how you do it as long as you get to a final answer in scientific notation. We look at the next problem, 0.3 times 1.3 times 10 to the third. We're going to just multiply the 0.3 times the 1.3. And this is still times 10 to the third. That's basically what you're doing. So if I take 0.3 and I multiply that by 1.3, I get 0.39 times 10 to the third. Okay. If I wrote that in standard form, that would be 390, because I would move it 3 places to the right. Transferring that back to scientific notation, it would be 3.9 times 10. We move boom, boom to the second. So we have 3.9 times 10 to the second. Last problem, 2.5 times 6 times 10 to the third. So we're going to multiply the 2.5 times the 6. And we're going to tack on the power of 10. 2.5 times 6 is 15. So I have 15 times 10 to the third. But that's not in scientific notation. I need to write it into scientific notation. Okay, 15 times 10 to the third would be 15,000. And then all I need to do here is transfer it back to scientific notation. So I would move my decimal point here. So it's 1.5 times 10 to the fourth power.